All right, calculus, here is number one. The differentiation on these is not going to be hard because we're going to do some analysis of these functions to figure out where we have relative extrema. So what does it mean to be relative extrema? Remember, extrema is a fancy word of saying maximum or minimum. So the first thing I need to do, remember, to find our maximum and minimum, we have to know what is the derivative going from positive to negative or negative to positive. So if you look up here at this graph, our maximum and minimums would occur here, or had this kept going up, it would have occurred here and here, right, for maximum and minimum. This is where it went from increasing to decreasing, that's a maximum. My derivative went from positive to negative. So the places where those maximum and minimums occur, like we said, is when the derivative is equal to 0. So in order to find those, I've got to first find what? The derivative, right? So f prime of x, the derivative of f of x, it's going to be 5 times 3, which is 15x to the 4, 5 minus 1. And then 3 times negative 5 is negative 15. X to the 3 minus 1 is x squared. So there's my derivative. My relative maximum and minimum I know would occur, or whatever this derivative is equal to 0. So I'm going to factor out, looks like they have 15x squared in common. And I've got x squared minus 1 left over. So then I've got 15x squared times x minus 1, x plus 1. And so my minimum or maximum is going to occur either at 0, 1, or negative 1. Okay, so then if I ask you, well, which one of those is the minimum, which one of those is the maximum, are they all maximums, or are they all minimums? We've got to analyze these guys. So think about our graph. Just going to make a number line here. They're going to occur at negative 1, at 0, and at 1. So at these three places, they are most likely going to cross a graph going from, the derivative would go from positive to negative, negative, positive, and that's going to tell us whether we've got a maximum or a minimum. All right, so then I want to test something in here. So this is my derivative, and then this is going to be what's happening to f of x. Let's figure out what is happening to the left of negative 1. Pick any number you want less than negative 1. I'm just going to choose negative 2. Because why not? When I plug in negative 2 into my factored form, so I'm plugging it into the factored form here. Actually, I don't even need to write all this, but we're going to test negative 2. If I plug in negative 2 into here, I have 15 times negative 2 squared. That's going to make it positive. Positive times a positive is positive, right? And again, negative 2 squared here would be 4 minus 1. That's 3. That's a positive times a positive. And so that overall guy is going to be positive, and so f of x is increasing when we're less than negative 1. At negative 1, we know we're at 0, right? What's happening between 0 and negative 1? All right, what's a number in between 0 and negative 1? This is where it gets kind of tricky. I'm going to test negative 1/2. Well, I know a negative times a negative here is going to be positive, times 15, that's going to be positive. This is the part where I really have to think about. Negative 1/2 times negative 1/2. There's of you that are fractionally challenged, that would be positive 1 over 4. So this would be 1/4 minus 1. Is that going to be positive or negative? 1/4 minus 1 would be negative. So this guy would be positive times negative, which is negative, which means in this portion of the graph, we're going to be decreasing. My function graph is decreasing. My derivative is going to be negative there. Function graph is decreasing. All right. Likewise, let's pick 1/2 in here, right? Positive times a positive is always going to be positive. And then 1/2 times 1/2 would be 1/4. Again, 1/4 minus 1 is going to be negative. Positive times negative is negative, so we're going to be decreasing in this section. And then when we're bigger than 1, let's choose 2. What happens when we plug in 2? 2 squared is 4 times 15 is 60. That's positive. 2 squared is 4 minus 1. That's 3, which is also positive. And then positive times positive, that's going to give us a positive number. So our function graph is increasing. All right, so we know if our function is increasing and turns to decreasing, what's happening? Increasing, decreasing. Here we have a max here. Going decreasing to decreasing, this is actually going to be an inflection point, but we haven't really talked about that just yet, but that's what's happening there. And then if I go from decreasing to increasing, decreasing to increasing, I've got a minimum point here. All right, so they want us to come up with 4 things. 1, where is f of x decreasing? I'm going to say f of x is decreasing on the interval, what was that, -1 to 1, because f prime of x, the derivative, this guy here, is negative. But you could also put that symbolically, but f prime of x is less than 0. All right. They also want to know, where is f of x increasing? Well, f of x is increasing on the intervals. Now we're going from -infinity to -1. Oops. Union, and we start increasing again at 1 to infinity. Why? Because the derivative is greater than 0, is positive. All right, and then they want us to find maxes and mins, and we found them right here and right here. So f of x has a relative max at x equals -1. Why? Because f prime of x goes, I guess we don't really want to say goes, more mathematically changes from positive to negative at x equals -1. And then for our minimum, that's occurring at 1. So we can say f of x has a relative minimum at x equals 1, because f prime of x, this time we're going to change from negative to positive at x equals 1. And so this is a very, very common type of problem that they'll give you on the AP exam, where they want you to analyze some function and figure out where are the maximums, where are the minimums, where is it increasing, where is it decreasing. You will most likely see this for sure somewhere on your free response. So we'll have lots of practice of this. Come back and we'll do the second problem.